Good morning. Today we're going to be looking at putting together the idea of our IntNode, looking at the basic structure of using C++ to examine what it takes to make a data structure, and then going on from there. As you can see right here in our IntNode diagram, you can see that we have our UML for setting up our IntNode and our associated IntNode array. On looking to start off just with the IntNode itself, you can see that we have in our data members section, we have a couple of data members we're going to have to keep track of. We have a couple of basic data members that belong to the IntNode object. We have a int that is stored in it. It's called node data. And then we have a node pointer, which is of type IntNode pointer, again a reference to the type that we're using itself, so it can point to the next IntNode as needed. On the methods that we have a getters and setters for this, because the idea of when we're building our data structure, the main component of the node itself, the actual thing we're building, it's basically just going to have the ability to get and set that information and have the associated values with that. And these are going to look a lot like all the getters and setters been looking. And then we have in the constructor section, as you can see, I'm using 3 separate constructors right here. I have my default constructor just to show the idea of how a constructor can be built using C++ as a nice little reminder. We have our more common version of using the constructor where we pass a specific value. And finally, our third version of the constructor, the IntNode, that takes both a value as well as a node as a parameter, so we can build an object with the specific values information that we need to go from that. So as you can see, just by the name right here, we can see that we're specifically dealing with the idea of a node that can only hold ints. We have it explicitly defined right here as we look at that lovely piece of information that we are only dealing with ints inside that framework. Why it's so important that we need to actually have a generic data structure we can use to build for a variety of things. Otherwise, we're going to be forced to actually make int node, string node, car node, toast node, billions and billions of things that we have to store. We'll have to make a separate file for each of them and do all the logic on top of that every single time we want to make that. And so it's very important when we see why the idea of not having to make individual things is more important, that we can use the idea of a generic structure or a typed to make individual type things as we need them. And we'll look at how to use C++ templates to make that happen in just a bit. So what we're going to go ahead and do is we're going to go ahead and take a look at the actual code to go for that. So let's go ahead and move to the header file of IntNode. As we look right here at the header file on this right here, you can see that our class IntNode is defined just like regular class inside C++. We're using 2 sections, a private and public section. As you can tell in the private section, we have those 2 data members we were talking about. There are no private methods when we're talking about making the IntNode right here, because the methods that exist inside the node object are all going to be public because we used externally by the data structure that is composed of them. We then look at the fact we have our constructors right here. We have our default constructor, a constructor takes a value, and then we also have a more powerful constructor that takes as a parameter set the value that's going to be put inside it, as well as a link to the next node it will be connecting to. And so we can see that right there. We also have a couple methods right here. I've grouped them on the getters and setters. We have our get node data, which returns of type int because it's what's stored inside it, and then a pointer reference to get the pointer that goes along with it as well. We also have our 2 setters that go along with it, taking as a parameter for each of them a type of int or type of IntNode pointer. So we have that basic structure. We can see how that's being set up. Again, just for the idea of basic structure of a C++ class, you'll notice that we start with a hashtag ifandef or pound ifandef, and then hashtag define, and ending with hashtag indef. That structure is what we're going to see for every single C++ class that we do. So we're not going to go over that again, but just as an FYI, that's always going to be there. And again, always in C++, remember that your classes end with our great friend, the semicolon. And then as a reminder, inside the header section of the class, what we're seeing basically is the idea of creating the prototypes that would exist normally inside a single file if we're doing a non-standard form of C++ for class. It's just like a regular Java interface where we define the prototypes inside here, but because it's C++, we also do our definitions of our constructor headers, etc., all here as well. So let's take a look at the associated implementation file, or the CPP file. We take a look at the CPP file. As you can tell, just with every single thing, we're always starting with the pound include or hashtag include for the header file that's built for this, that defines the class. We see right here we have the hashtag include intnode.hpp. We explicitly define that we're going to be using the HPP file or the header file for this, so we can actually have that predefined list of information we have to be ready to be able to see and use and have as an information we can use later on inside our program as we do more complex stuff. And we'll see that in just a bit in our next video. We then have our constructor section. Just like with every in Java, we have the idea the role of the constructor is to initialize the data members. As you can see right here, we have the idea of using the initialization of the data member of this selector node pointer is equal to null pointer, and this selector node data is equal to -9999. Now, the reason I'm explicitly defining the node data value as -9999 is because of the fact that we want to explicitly know when we are testing this code out that we have not somehow accidentally just created some random int which has a default value of 0. By giving it this default value of negative 99.99, we know we've explicitly accessed an unused piece of information, and so we haven't actually set the value appropriately. And so this way we can quickly see that right away. It also makes it very easy to test and do debug when we're looking through our structure for that. On the initialization of the node pointer, we're using the keyword or reserved word null pointer because we don't want to have any problems with compilation as we actually build our project, because although all pointers for a default value are ints and we could assign a value of 0 for that, by using the reserved word of null pointer we explicitly define that we are using this as a pointer, and there's no reason for us to be, as a human beings, to be confused, nor for any possible confusion versus the compiler we're using. Now, if we take a look right here, we're also using the reserved word this to talk about the this pointer. I love the fact that we can explicitly define this within C++ automatically by using the this pointer and making sure to keep reference to that, which requires us also to use the selector operator. However, we could also simply just do node pointer equals null pointer. And that does work, but I like the idea of actually using the more explicit definition that we're talking about the current object. It forces us to always think that we're using this and we're actually paying attention to what we're designing for our code. So then we have our default constructor right there. Pretty basic, pretty easy to go. We then have our more explicit constructor, the one that takes an individual parameter as of an int value. And so just like we see inside our previous constructor, the node pointer is still initialized to null pointer because we don't know what it's pointing to. It's a default value. It's simply just a node pointer that's pointing to null because we don't know where it's going to go yet. However, we do want to explicitly initialize our data member, and I'm using the idea of the keyword right here a parameter of value. I'm assigning value into this selector node data. By doing that, we explicitly see that we are assigning into that parameter the value, or we are explicitly assigning into the data member node data the value from the parameter of value. So we have that right there. So we're creating our default constructor that has a value attached to it, but we don't know where it's pointing to. It's simply just there. Finally, we have our third constructor, and our third constructor is the constructor takes both a value as a parameter as well as a pointer as a value. Now in this case, we're using my more standard approach with Java where I say this selector node pointer equals node pointer. I have the same variable name right here, node pointer, node pointer, node pointer, but because I'm using the this selector operator, that means I know that I'm talking to the data member one right here on the left-hand side of the equal sign, or the L value, whereas the R value, because it doesn't have that this pointer operator attached to it, we are definitely using the parameter operator, or parameter version, excuse me, for its R value on that. And that's what you want to make sure you take a look at, that you keep your L value and your R values, or the assigned into and the from values, correctly matched up. Generally, it's a great idea to make sure you always use the this pointer, especially if you use the same variable name. You can always explicitly define what that is. We again are also setting the value in that, keeping the same approach for that. Looking over our getters and setters, if you take a look at the getters and setters that we have right here, you can notice that I can do the standard way of just simply saying node data equals new value. In this case right here, where I'm using a separate variable name referring to the node data, instead of using the more proper idea of using this selector node data, because I can explicitly define the fact that I'm assigning to this variable name node data the value that's stored inside new value. Now, of course, the more appropriate method is to always go ahead and have the this selector using that, so I can explicitly say that I'm talking about this current object and using that information for it. We look at our set node pointer. It's the same approach right there where I'm using this selector node pointer equals node pointer, just like we saw in the constructor up above. The setters for a method are just like what we see inside the lines of the constructor. This dot value, or this selector value, equals the associated value passed as a parameter. Really easy, and just like Java for the basic structure we're dealing with. Again, the same approach happens inside the getters. In the case of IntNode getNode data, I'm returning simply node data. As you can tell by the green highlighting right here, we're explicitly using the data member for that. However, I could also use the this selector operator, so I can explicitly the fact I'm talking about the current object's node pointer. It's the same thing, it's just the more proper way of doing it is using the this operator, so we can always know that we're talking about that right here. Just a bunch of simple one-line methods for our IntNode getters and setters. Just like in Java, the getters and setters are very simple code that we simply have to put in so we have access to the information, we can use it as needed. Not the complexity of the code, but the fact that we have the basic structure for that. Then let's take a look at the actual structure of how we build the class. As you can see, all these are methods of the IntNode object, and so we use the name of the class and then scope resolution, and then its associated either constructor or method that goes along with that. The class name scope resolution operator go between the return type and the method name. This indicates that the method on the right-hand side of the scope resolution operator belongs to the object specified on the left side of the scope resolution operator. So we have this class has a method called setNodeData. This class has a method called setNodePointer. This class has a method called getNodeData. We use that information so we can explicitly show that the method specified belongs to or is a member of the class on the left-hand side. So that scope resolution shows that relationship. There are some shortcuts you can use to get around this so you don't have to show all the information, but because of the fact we're using a design structure, we're trying to explicitly define how this code itself relates to it, we are going to always use a nice clean set of naming conventions and the idea that we're explicitly defining that this int node belongs to, this method setNodeData belongs to the class IntNode. We will always explicitly use that in class because we're going to always have a strong correlation between what we're using in class and the actual design principles we're working with that. Now, again, as we saw earlier when we were looking at the actual design diagram, we have right here that this is only going to hold ints. We can't use this IntNode object to hold anything else. We can't hold chars in here, we can't hold booleans in here, we can't hold cars in here, we can't hold Pokemon in here, we can't hold anything besides ints. Now, this drastically limits what this code can do because of the fact it's specifically built only to use ints. We are going to see the fact that we can, because of this, we would, if we wanted to have a more powerful set of tools, if we wanted to make a lovely multi-tool data structure, then we'd have to have an associated set of files for all of these. We have to have intnode.cpp and associated.hpp as well as a stringnode.cpp, stringnode.hpp, all the way down for any type of data structure we wanted to specifically store if we're using this one single type attached to it, so it can only hold this information. And then on top of that, we'd also have to make our string node array, our car node array, our Pokemon node array. Everything would have to have its own separate type of data structure on top of that. So it's very important that we see the value that by making, although this is very simple and easy to work so it can use simply just one type, the fact that we have explicitly defined one type means it's very restricted in how much information it can actually use. So it's important that we actually go through and decide how we're going to put this together. So here we have, again, just a quick review of what we have. We have on our design, we have our IntNode data structure. It has a couple data members that belong to it, really quick and simple. It has 4 methods that belong to the node itself, and the fact that we have 3 constructors to build it in 3 different ways, depending on how we're going to be using the information inside the object. It is also related to our IntNode array, which will be seen inside our next video. Quick review of the HPP file. Again, the header, just the same, almost exact that we saw of the UML diagram. We have our data member section right here, always in the private, and then inside our public section, we have our methods and constructors that we have access to. Had this been a more complex thing, obviously we'd have methods up here in our private section, but because this is really basic, we're simply going to create and use those values right here. Now, I have int nodes, they're great, they're wonderful, but on their own they don't do very much. But we have the idea that we have a basic structure we can see and use to hold and store int values when we're building our data structure. And we're going to take a look at that next. Thanks, and have a great day.